In this video, we're going to be looking at the equations of lines, and then we're going to be graphing lines a little bit later. All right. We're going to be looking at something called intercepts today. An intercept is where the graph of an equation crosses a certain axis. We're going to be interested in x-intercepts and y-intercepts, right? An x-intercept is where the graph of the equation crosses the x-axis, and a y-intercept is where the graph of the equation crosses the y-axis. So as you can see in this little diagram right here, anytime that the graph crosses the x-axis, like right here and right here, we call that an x-intercept. What's true about the coordinates of every x-intercept? Okay, well, if we were to look at this here, this is at about the point 3 comma 0. And then this point is at about, well, 4, 5, 6, 7, 8. That's at about 9 comma 0. And notice that both of these x-intercepts have a y coordinate of 0. So the y value always equals 0 for an x-intercept. All right, here is where our graph crossed the y-axis at this point right here. 1, 2, 3, 4, that's at about 0 comma 5. All right, what's true about the coordinates of every y-intercept? Well, on every y-intercept, the value of x is 0. Okay, so if you're on a graph and you want to find your x-intercepts, then just set y equal to 0. X comma 0 is going to be an x-intercept. And if you want to find a y-intercept, set your x value equal to 0. All right, 0 comma y is going to be the coordinates of any y-intercept. In this example, we're given this graph of a line, and we're going to use this graph in order to find the x-intercept and the y-intercept. Okay, so remember, the x-intercept is where the line crosses the x-axis. So here's your x-axis, and here's the point where the line goes over the x-axis, and it has coordinates of 3 comma 0. The y-intercept is where the line crosses the y-axis. So here's your y-axis, and here is the point where the line crosses the y-axis, and that's at 0 comma 9. All right, they would like for me to find the slope of this line. Okay, so I've just identified 2 points that are on the line. I could set up my slope formula. M equals delta y over delta x. And if I wanted to calculate the change in y values, okay, I could call this y2 or this point 2 and this point 1. So I'm going to do 9 minus 0 for the change in y's, and then I'm going to do 0 minus 3 for the change in x's. And if I were to evaluate this, 9 minus 0 is 9, 0 minus 3 is negative 3, and 9 divided by negative 3 is negative 3 over 1, or negative 3. So the slope here, m equals negative 3. M equals negative 3. And this tells me how to get from point to point on my line. Okay, I'm going to go down by 3 units and then to the right 1. So here I am at 9, 0. If I go down 3 units, 1, 2, 3, and then right 1, I'm still on the line. Down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1. Okay, that would get me from point to point on my line by using the slope negative 3 over 1. In our next example, I was given this function table. I'm going to use that function table to answer a few questions. Okay, so here are my inputs. Remember that x represents the input of the function. Okay, and y is going to be the output of the function, and sometimes we call that f of x. The function rule, it says y equals negative 5/3 x plus 1. So what they did, they took these inputs and they substituted them in for x into this equation, and that calculated these outputs, making these equations, or these points rather, these ordered pairs. So these are the points that form the line from this function rule. What we're going to do in part A says calculate the slope using any 2 points from the table. All right, I just need 2 of these points to calculate the slope. So why don't we use this point right here? We'll call that point number 1. And then we'll use this one over here. We'll call that point number 2. And again, I didn't have to use these two. I could use any 2 points, but I'm just going to use these for this example. So to calculate the slope, m equals, it's delta y over delta x. And to do delta y, I need y2 minus y1. The y2 value is negative 4, minus the y1 value is 11. And then for delta x, I need the x2 value, which is 3, minus the x1 value, which is negative 6. All right, let's see if we can evaluate these. Well, negative 4 minus 11 is negative 15. And 3 minus negative 6 is the same as 3 plus 6, which is 9. So I get a slope of negative 15 ninths, but both of those numbers are divisible by 3. And so if I were to simplify this, I would end up with negative 5 thirds. M, the slope of this line, is negative 5 thirds. Question B asks, what are the coordinates of the y-intercept? Okay, well, remember that your y-intercept is found on the y-axis, and any point on the y-axis has an x value of 0. Okay, so for a y-intercept, I'm looking for when x equals 0. And if I look at my list of inputs here, x equals 0 gives me an output at negative 1. Okay, so the coordinates of the y-intercept is 0, negative 1. The y-intercept is at the point 0, comma 1, because the y-intercept always has an x-coordinate of 0. All right, and so again, I went to my list of inputs here. When x was 0, y was equal to 1, so the y-intercept is found at 0, comma 1. All right, well, letter C asks, what connection do you see between the function rule and the slope and the y-intercept? Okay, well, the function rule we can see right here. The function rule said y equals negative 5 thirds x plus 1. Okay, and looking at this example right here, well, the slope was negative 5 thirds. And so that's what I see right here. All right, what connection do I see between the function rule and the slope? All right, well, the slope is the value that multiplies the input values. All right. The slope is the value that multiplies the input values. I took all of these inputs and I multiplied them by negative 5 thirds. So the slope multiplies the input values. And then, well, what about the y-intercept? The y-intercept was at 0, comma 1. And at the end of my equation, I had to add 1. Okay, so the value of the y-intercept, the value of the y-intercept gets added at the end. Okay, and so those are two really nice connections to see between the slope y-intercept and the function rule. All right, the slope multiplies your inputs, and then you add the value of the y-intercept, and that gives you the value of your output. In our next example, we have another function table that we're going to use to answer some questions. All right, so here are the input values for x. This is the function rule. It says y equals 1 half x minus 1. And then these were the output values. So again, we took these inputs, we substituted them into this rule, and it created these outputs, meaning that these ordered pairs are points on the line of our function. Letter A says calculate the slope using any 2 points. So again, we can pick any 2. Let's use this one. This will be point number 1. And let's use this one. This will be point number 2. Again, I can use any 2 points, but those are the 2 that I'm going to go with. M equals delta y over delta x. So to calculate delta y, I've got to do y2 minus y1. y2 is 4 minus y1 is negative 3. And then for delta x, I need x2, which is 10, subtract x1, which is negative 4. And now if we calculate this, 4 minus negative 3 is the same as 4 plus 3, which is 7. 10 minus negative 4 is the same as 10 plus 4, which is 14. And 7/14 simplifies down to a half. So the slope here, m equals 1/2. Letter B, what are the coordinates of the y-intercept? How do you know? Well, again, the y-intercept is found at an x-coordinate of 0. So here's where our x input was 0. It gave us the y value of negative 1. So 0, negative 1 is where the y-intercept is, because the x-coordinate of the y-intercept is always 0. Okay, so again, always find where x equals 0 in order to get the coordinates of the y-intercept. All right, and very similarly to the last example, what connections do you see between the function rule and the slope and y-intercept? Well, our function rule, y equals 1/2 x minus 1. 1/2 was the value of our slope, so the slope multiplies the inputs. The slope multiplies the inputs, and the y-intercept gets added at the end. Okay, our y-intercept was 0 comma negative 1, and at the end they're subtracting 1, which is the same as adding negative 1. So again, the slope multiplies the inputs, the y-intercept gets added at the end. Y equals 1/2 x minus 1. So hopefully in the previous examples, you've seen a connection between the slope and the y-intercept and the function rule in our examples. All right, in this problem, I've given you a graph. All right, line A and B were graphed together. For each line, we're going to state the slope and the y-intercept. All right, so if we look at line A, if we want the slope, well, all we have to do is find a couple of points that are on it. So here's one point on line A. Here's another point on line A. To find the slope on a line, I'm going to find the vertical rise. So I went up 1, 2, 3 units, and then I went right 1, 2, 3, 4 units. Okay, so for the slope of line A, I'm going to have 3/4. All right, rise over run. We went up by 3, right 4. Up by 3, right 4 gets me to another point on the line. The slope is 3/4. Looking at line B, again, just find 2 points that are on the line. All right, here's these 2 points. I'm going to have to rise 3, and then I'm going to have to run to the right 4 units on line B. So this slope is also 3/4. Up 3, right 4, up 3, right 4. The slope of each line is 3/4. Okay, and that's not a coincidence here. If you look at these two lines, well, these lines are actually parallel to each other. And parallel lines are never going to intersect, which means that their rate of change or their slope is going to have to be the same. All right, so we get a slope of 3/4 for every line here. Now, what's the y-intercept? Okay, well, the y-intercept of line A, it hits the y-axis right here at the origin, which is 0, comma 0. All right, and for line B, it hits the line right here at 0, comma 4. 0, comma 4. Well, based off of this, can you write the equation of each line? Okay, well, if we think about our function rules started out as y equals. All right, our output value equals, and that's what we're going to have on both of these, y equals. Y equals. All right, to get the output value, what do we have to do? Well, in our previous examples, we took the value of the slope and multiplied it by the input x. So for these examples, we're going to take the slope for each line, it was 3/4. and multiply by x. 3/4 times x, the slope times the input. Then what we had to do was take the value of the y-intercept and add it at the end. Okay, well, the value of the y-intercept, it's when x equals 0. Here, when x was 0 in line A, its y value was 0, so I could write plus 0, but that's just the same as saying y equals 3/4 x. Okay, so that would be the equation of line A. In line B, when x was 0, y was 4, so at the end I would add that value. The equation of line B is y equals 3/4 x plus 4. So again, the slope multiplies the input values, and then the value of the y-intercept gets added at the end. To get the output value, y equals 3/4 x plus 0 for line A, and y equals 3/4 x plus 4 for line B. So in our previous example, we wrote down the equation of each line. Okay, I can bring that back right here. The equation of line A was y equals 3/4 x plus 0, which is the same as y equals 3/4 x. The equation of line B is y equals 3/4 x plus 4. All right, the way that we have written each equation is called the slope-intercept form of the line. And that's what we have here in this box. A non-vertical line can be modeled using the equation y equals mx plus b. All right, that is known as the slope-intercept form of the line. Y equals mx plus b. M, of course, is the slope. We've been referring to the slope as the variable m for a few lessons now. Remember, to calculate slope, you do delta y over delta x, or the change in y over the change in x. All right, so m here is the slope. The slope multiplies the input. And then b is the y-intercept, which again is where the line crosses the y-axis. The y-intercept gets added at the end. Y equals the slope times the input plus the value of the y-intercept. This again, y equals mx plus b, is called the slope-intercept form of the line. And what we're going to want to do in the next examples is for each graph, can you write down the equation of the line in slope-intercept form? In order to do that, we have to figure out what's the slope of the line and then what's the y-intercept of the line. And that way we can write the equation in slope-intercept form. So let's start with this line right here, okay? The y-intercept, the value of b. Well, the y-intercept is at this point 0, comma, -1. 0, comma, -1 is where the line crosses the y-intercept. So when x is 0, y is -1. So in this example, b equals -1. For the slope, all we have to do is figure out how we get from point to point on our line. So if I started here, to get to the next point, I had to rise by 2, and I had to run by 1, 2, 3, 4. All right, slope equals the rise of 2 over the run of 4, which just simplifies to 1/2. M equals 1/2. So if I start at any point to get to the next one, I'm going to rise 1, go to the right 2. Rise 1, right 2, rise 1, right 2, rise 1, right 2, rise 1, right 2, and so on and so forth. Okay, well, now I'm going to write the equation of my line in slope-intercept form. Remember, y equals mx plus b is the slope-intercept form of the line. So to get y, the output value, I'm going to take the slope, which in this case was 1/2, and multiply it by x. And then I'm going to add the y-intercept. So I would be adding -1 in this example, which is just the same as subtracting 1. The equation of this line is y equals 1/2 x minus 1. All right, so I could label this line with its equation, y equals 1/2 x minus 1. Let's try it on this line. All right, here's our line. The y-intercept is found at this point right here, which is at 0, comma 5. So when x is 0, y is 5. And so that's the value of b, your y-intercept. For the slope, how do we get from point to point? Well, I'm going to be going down vertically, and I had to go down 3 units, so that's going to be a negative 3 over, I went to the right 1. M equals negative 3 over 1, which means that the slope M is negative 3. To get from point to point, I have to go down 3, right 1, down 3, right 1, down 3, right 1, and that gets me from point to point. Okay, so to write the equation of the line, y, the output, equals the slope times the input. The slope is negative 3 times the input of x, and then I have to add the y-intercept, which in this case is 5, plus b. All right, y equals negative 3, y equals negative 3x plus 5 is the equation of this line. And so I can label that as well. Y equals negative 3x plus 5. Now that I know how to write the equation of a line from a graph, I'm going to see if I can come up with the equation first and then graph the line. So in our next example, I know that the line goes through the points negative 1, 5 and 2, 8. The first thing I'm going to do with those 2 points is calculate the slope of the line. So m equals delta y over delta x. All right, I'll call this point number 1 and this is point number 2. So to calculate delta y, y2 minus y1, 8 minus 5. For delta x, x2 minus x1, 2 minus negative 1. And now if we simplify this, 8 minus 5 is 3. 2 minus negative 1 is 2 plus 1, which is also 3. 3 over 3 equals 1 over 1, or 1. So the slope of the line, m, equals 1. Okay? So what we're going to do now, we're going to plot our 2 points, negative 1, 5, and 2, 8. All right, 2 comma 8, which is right there. All right. And now I'm going to use my slope to find additional points that are on the line. The slope here is 1, which is 1 over 1. So I'm going to rise 1, go to the right 1, up 1, right 1. So up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. All right, there's a bunch of points that are on that line. Now I'm going to use my ruler here and I'm going to connect the points. All right, and I'm not going to stop at that last point. I'm going to extend through it so I can even get more points that are going to be on that line. So let's go ahead and do that. Connect all of our points. And I get this nice graph right here. I'm going to put an arrow on both ends of my lines because that line is going to go on forever. Okay, so I've connected all my points. Now I want to know what's the y-intercept of my line. Well, the y-intercept, again, is where the line crosses the y-axis, which I can see is right here at the point 0, comma 6. So when x is 0, y is 6, so the value of b is 6. And now I can write the equation of my line. Y equals mx plus b is the slope-intercept form. So y equals, the slope is 1, so I can put 1x plus b, which in this case is 6. Y equals 1x plus 6, or I could simply write that y equals x plus 6. Either one of these would be a good equation, and now I'm going to label my line with that equation. Y equals x plus 6. In my next example, I've been provided with the equation of the line. I'm going to use this equation to identify the slope m and the y-intercept b, and then I'm going to graph my line here. I'm going to label the graph with the equation. Okay, so remember that in slope-intercept form, the equation is y equals mx plus b. And so this is going to be very easy for me to pick out the values of my slope and y-intercept. All right, the slope m is right here, which is 4. M equals 4, which remember is the same as 4 over 1. The y-intercept b is what was added at the end. We added -3. So the slope, excuse me, the y-intercept here is going to have a b value of -3, which means the coordinates are going to be at 0, comma, -3. The y-intercept always has an x-coordinate of 0, 0, comma, -3. So let's plot the y-intercept first, 0, comma, -3. 0, comma, -3 is right here. And now I'm going to use my slope to find other points on the line. The slope was 4, which is 4 over 1. I'm going to rise 4 and then go to the right 1. So let's rise 4. 1, 2, 3, 4. Right 1. There's a point. Rise 4. Right 1 for another point. Rise 4. Right 1. And there's another point. Now we can use our ruler and connect all of those points. But again, we're going to extend in both directions as far as we can so that we can get even more points. And there's our line. Put arrows on both ends. And I'm going to label this line with its equation, y equals 4x minus 3. Okay, it's got a y-intercept as 0, -3. And then I rise 4, right 1. The slope of the line is 4.